So now we'll start about mechanism of chemisorption. Chemisorption. So here chemisorption. Example, adsorption of hydrogen on nickel surface. It is an example. If you take nickel metal here, this is nickel atoms like this. This is nickel. So nickel atoms are like this. So hydrogen molecule. First two steps are involved. First step, adsorption takes place. Observe, hydrogen molecule is adsorbed on the surface of the nickel metal. So here, this first step is called as adsorption. So this is nickel, and here also nickel atom and hydrogen, nickel, and here nickel. So this is hydrogen. So this is adsorption. So here this is adsorption. After that, dissociation of the hydrogen molecule. Next step is dissociation. Dissociation after simultaneously chemisorption takes place. Here nickel and nickel. This is hydrogen. And this is nickel. And nickel atoms. These are like this. So first step is adsorption. So it is absorbed on the surface of the nickel metal. After that, this hydrogen molecule is dissociated and it is bonded to the nickel atoms by covalent bond. So this is mechanism of chemisorption. After that, differences between physical absorption and chemical absorption. What are the differences between physisorption and chemisorption? So I will discuss about differences between physical absorption and chemical absorption. Differences between physisorption and chemisorption. So this is differences between. So these properties I will discuss with the one word that is called star Nell. This is star Nell. So what is star Nell? Here first, physisorption and chemisorption. Physisorption and chemisorption. Here, so first property, yes means specificity. Yes means specificity. Next, T means temperature. So yes means specificity, T means temperature, A means activation energy. A word mentioned, activation energy. R means reversibility. N means nature of forces. Next one, E means enthalpy. Next, L means layers form. Next, P means pressure. So by remembering this word, you can write the differences between physical adsorption and chemical adsorption. So physical adsorption and chemical adsorption here. So that word is star nil. So that word is star nil. So first one is specificity. So physical adsorption is not specific. Physical adsorption is not specific, but chemical adsorption is highly specific. Highly specific. What is specificity means? Without any instantaneous it is formed. But if chemical bond only formed, then only formed. That is highly specific. The word is mentioned for that, highly specific. Temperature. So low temperature is favorable for the physics option. High temperature is favorable for the chemies option. Activation energy, low activation energy. What is activation energy? The minimum energy required to form the threshold state, to enter into activated state. The minimum energy required to form the products is called as activation energy. Here, low activation energy is required. Here, high activation energy is required. Reversibility. Here it is reversible. Forward reaction, both are observed here. High, it is irreversible reaction. It is irreversible. Nature of forces. Which bonds are responsible for the physics option? Which bonds are responsible for the physics option means which bond? Weak van der Waals forces. Weak van der Waals forces are responsible for the nature of forces. For the chemies option, chemical bond forces are responsible for the chemies option. So enthalpy. Here enthalpy value is 20 to 40. Here enthalpy is very low, that is 20 to 40 kilojoule per mole. So here 40 to 400 kilojoule per mole. 40 to 400 kilojoule per mole. Here layers formed. Layers. So physical absorption is multi-layer. It is formed in the multi-layer, but it is unilayer. Unilayer pressure. Same effect is there for pressure. If pressure increases, physical absorption is also increases. Pressure increases, physical absorption also increases. It is also pressure increases, chemical absorption is also increases. So these are the differences between physical absorption and chemical absorption. The word is star nil. Star nil. NELP. S stands for specificity. T stands for temperature. A stands for activation energy. R stands for reversibility. N stands for nature of forces. E stands for enthalpy. And L stands for layers formed. Multi-layer or unilayer. Like that. So P stands for pressure. So these are the differences between physical adsorption and chemical adsorption. So here specificity, temperature, activation energy, reversibility, nature of forces, enthalpy, layers formed and pressure. In this sequence, how to remember? Star nil. Star nil, how to remember. After that, so characteristics of adsorption. Characteristics of adsorption. It is also called as mechanism of adsorption. Mechanism of adsorption mechanism. So actually it is adsorption process is a specific and selective. It is specific and selective. And it is adsorption is exothermic reaction. So exothermic process. It is exothermic. Second property is or second character is exothermic, and it is the surface phenomena. And also one more important point is surface phenomena. So it is surface phenomena. Third point. And fourth point is spontaneous. It is spontaneous process. These are the characteristics of adsorption or mechanism of adsorption. So you know the formula delta G equal to delta H minus T delta S. So delta G equal to delta H minus T delta S. So delta H is change in enthalpy, delta G is change in free energy, gives free energy, and delta S is T is absolute temperature, and delta S is entropy. Entropy means randomness in the system. For any system, for a spontaneous process, I will take first spontaneous process. For spontaneous process means Gibbs free energy value will be negative. Delta G value is negative. For negative value of any system having negative free energy value, then decrease in the randomness. Randomness means entropy will decrease. Therefore, T delta S is also negative. After that, delta H it may be decreases. It means delta G value negative for the system. Randomness also decreases. For less randomness, delta H value is negative. Less randomness, delta H value equal to negative. If delta H value negative means that is exothermic process. So here it is a spontaneous process. So for spontaneous process, delta G value is negative. Negative means in a system delta G value is negative. Randomness gradually decreases. Randomness means entropy. Entropy decreases. So negative entropy means delta H is also negative. For this negative means that is exothermic process. It is a exothermic process. And simultaneous at equilibrium. In case of this is for spontaneous process. For spontaneous process, it is exothermic and delta G is negative. All are negative sign only for spontaneous process. And for an equilibrium, delta H value equal to T delta S value. Therefore, delta G value becomes 0 at equilibrium. This is the mechanism of adsorption. So adsorption is a specific and selective process. It is exothermic process, and it is a surface phenomena and also spontaneous process. In any spontaneous process, delta G value is negative. Simultaneously, randomness or entropy decreases. Due to decrease in the randomness, delta H value is ultimately negative. Therefore, it is a exothermic process. Energy is released. So, it is an exothermic process. In consider an equilibrium, delta H value equal to T delta S value, then delta G equal to 0. The free energy, Gibbs free energy value is 0. So, this is the mechanism or characteristics of adsorption.